Good evening. I'm PJ O'Neill, serving as branch chief for STEM training. Welcome to this month's Tech Talk, presented by Mr. Brendan DeSernia, who is from Eastern Shipbuilding Group. Eastern Shipbuilding Group is building the latest, most advanced fleet of cutters for the U.S. Coast Guard. Tech Talks are sponsored by the U.S. Coast Guard, the Coast Guard Auxiliary, and the Boy Scouts of America Sea Scout program. Tech Talks are held on the fourth Tuesday of the month at 2100 Eastern. Next month's Tech Talk is on August 22nd, focusing on radar, presented by the National Weather Service's Radar Operations Center. Just a reminder, this Tech Talk is being recorded and will be posted on both the Sea Scout and Aux Scout YouTube channels. If you haven't already subscribed, please subscribe to those channels. These recorded videos make excellent training with your shipmates, whether in your Sea Scout ship or in your auxiliary flotilla. They are free and available anytime. Please share the links with your shipmates that might miss tonight's Tech Talk. I would like to introduce our subject matter expert, Brendan DeSernia, but for that, I'm going to pass it along to Branch Assistant Hiram Muscabi.
Good evening, everyone. Tonight we have a very exciting presentation by Mr. Brendan DeSernia. He is the OPC Deputy Program Manager of Eastern Shipbuilding Group, and he has an excellent presentation how they build ships. So I'll hand it over to Brendan.
Thanks, Hiram and PJ. So thank you for the introduction. Again, I'm Brendan DeSernia with Eastern Shipbuilding Group in Panama City, Florida. We'll go a bit into company background, the Offshore Patrol Cutter program, and how we design and build ships. Here's my bio. So I've dedicated my career to the success of Eastern Shipbuilding's largest, most transformative program, being the Offshore Patrol Cutter program. I got into shipbuilding in the accounting department in 2013, right out of college, and ultimately moved into the OPC program when Eastern was one of 3 competitors for the phase 2 detail design and construction contract. So from there, I got into the program management side and oversaw the growth of the OPC program management department as it transitioned from detail design to construction. So I was born and raised in Panama City, where Eastern Shipbuilding Group is, and I graduated from UF in 2014 with a bachelor's in science. So a lot of ways to get into shipbuilding, whether it's STEM or in finance and program management or trades, which we'll get into as we go through the presentation. So ESG is that being Eastern Shipbuilding Group, is a high capacity, high quality shipyard. We've been in business since 1976 with over 350 ships delivered. One of these was the Andrea Gale that you may, recall from the movie The Perfect Storm, if you've seen that. That was hull 3. Since then, we've delivered over 350 ships, including fishing vessels, ferries, dredges, tugboats, towboats, offshore supply vessels, offshore wind support vessels, Coast Guard cutters, and more. So this presentation is going to focus primarily on the OPC program under construction at ESG. This slide gets into some of the resources and capabilities that ESG possesses to produce ships. There's a lot of acronyms here, but in shipbuilding, and especially shipbuilding for the U.S. military, there's a lot of significant management and engineering and production resources required. So just to explain a couple of the ones you're seeing on the screen from management resources, DCMA being the Defense Contract Management Agency, DCAA being the Defense Contract Audit Agency, certify a lot of business management and quality assurance systems, as well as ISO, the International Standards Organization, certifies quality and environmental systems as well. ESG has significant engineering resources, over 100 engineering and design staff with all the tools to perform preliminary design and 3D modeling. From a production standpoint, ESG has a significant level of resources to support a high rate ship production. including a significant footprint at 3 facilities. Another acronym, C5ISR, being your electronics, navigation, computer systems, et cetera. We have an on-site integration facility for the Offshore Patrol Cutter program. And we have a large workforce, 1,500 direct labor and subcontractor labor force. This allows us to do a lot of things from a capability standpoint, from gas turbine propulsion, again, C5ISR systems, machinery plant control and monitoring being your automation for your machinery plant, trade compliance, ACAT-1 being high-end government program management. So all of these resources support Eastern's capacity. So with these resources, we're able to deliver over 32,000 long tons that we've delivered in a single year at our peak. A long ton is primarily used in shipbuilding. It's actually 2,240 pounds. So you'll see that a lot if you get into naval architecture, shipbuilding, or operating ships. We've had as many as 23 ships in construction at a single time and 15 ships delivered in a single year. So that significant shipbuilding capacity and throughput and all of those resources are ultimately built on our people and the careers that they can have in the shipbuilding industry. Eastern Shipbuilding has 3 facilities in the Bay and Gulf County areas of Northwest Florida. All 3 of these facilities are highly capable, and they're co-located with significant military infrastructure in the area, including the U.S. Coast Guard, Navy, and the Air Force. And that better positions us to support our industrial base. And also, we live on the world's most beautiful beaches, so that's a fun thing too. Here you see our 3 facilities, those being our Nelson Street, Allenton Road, and Port St. Joe facilities. So these facilities have over 300,000 square feet of fabrication platens, being flat concrete foundations on which to build individual units that you turn into an overall ship, significant crane and lift capacity, and launchways. So our Nelson Street facility that you'll see in the top right is where we build the Offshore Patrol Cutter. So we've made a lot of investment there to support government production. Our Allenton Road facility in the bottom left is a large scalable facility. It's our largest at over 300 acres, houses our steel and aluminum processing facilities and our electronics test and integration facility. And our Port St. Joe facility, which is our newest yard in Gulf County, is really well suited for final outfitting and repair. So next, we'll get into the Offshore Patrol Cutter program and the platform itself. So Eastern is producing 4 OPCs. The OPC is a medium endurance cutter that'll form the backbone of the U.S. Coast Guard's fleet. So just the overall particulars, she's 360 feet long, has a 53 3/4 foot beam, that being width, and is 26.5 feet deep from the main deck to the keel or the bottom of the ship. For capability, she can hit 22.5 knots sustained, 9,500 nautical miles range, endurance of 60 days for provisions and stores, 126 accommodations for the crew. She can launch 3 operational small boats and hangar a helicopter up to an H-60. So that's a Black Hawk. Currently, the Coast Guard fields primarily H-65 Dolphins on their cutter fleet. So this advanced capability to hangar and maintain up to an H-60 really increases the capability of being able to support flight operations, which together with small boats form really the main batteries of a Coast Guard cutter. So the following slides will get into a bit of the mission and then the particulars of the ship. So this slide describes some of the required missions for the Coast Guard in general, and then specifically for the OPC. So as you can see, the OPC is designated for search and rescue missions, living marine resources being fisheries and wildlife enforcement, ports, waterways, coastal security, drug interdiction, migrant interdiction, defense readiness, and law enforcement. The OPC is intended to fill the gap between the Coast Guard's smaller cutters, the newest generation being the fast response cutter, and the largest cutters being the national security cutter, fitting between the shorter range mission of the FRC and the longer range mission of the NSC. So the US Coast Guard actually intends to build more total tonnage of OPCs than FRCs and NSCs combined. When you add up the entire program of record, you're looking at over 108,000 long tons of OPCs versus 50,000 long tons of NSCs and around 23,000 long tons of FRCs. So that's just to show it will be the workforce of the fleet. The Coast Guard will really carry out a lot of their primary missions through the offshore patrol cutter. And notice a couple of the missions the cutter doesn't perform, namely aids to navigation, which is primarily supported through buoy tenders and construction tenders, and then polar and ice and Alaskan operations, which are primarily through icebreakers. So the OPC, as discussed, is intended to replace the Coast Guard's 210-foot and 270-foot medium endurance cutter fleet. The primary takeaway here is the ships that the OPC is replacing are old, to put it as bluntly as possible. The Reliance class on the left, you see first fielded in 1964. In fact, WMEC 615, the Reliance, is still in service today. And the 270-foot cutters, first fielded in 1983. What you see there is WMEC 913 or the Mohawk. So not only are these ships old, it's harder to maintain them and overhaul them. And for older ships, they put them through a service life extension program. The 210-foot cutters have already been through them and are no longer really capable of that. And for the 270-foot cutters, those are really cost prohibitive. On top of their aging state, the missions have also significantly grown since this fleet was fielded. So the terrorist attacks of 9/11 have added a lot more coastal security. There's been new technology development. Environmental and habitability standards have increased. So all of this is to say that OPCs are very critical to the Coast Guard fleet, and Eastern's pushing to get them out as quickly as possible to help replace some of the aging capability of the older medium endurance cutters. This slide starts to get into some of the design of the offshore patrol cutter. So our OPC is a conventional twin screw, meaning two propeller, monohull, meaning the vessel only has a single hull design. So the hull form incorporates well known and proven design features to enhance sea keeping, reduce resistance, increase propulsive efficiency, and increase speed. So on the screen here, you'll see some following features that really help with the speed aspect. So on the aft end, you'll see a Costa bulb rudder with a twisted leading edge. A Costa bulb rudder being the propeller and the rudder actually come together to reduce hydrodynamic turbulence and improve speed. And the bulbous bow forward helps reduce and minimize drag. So the bulbous bow reduces resistance as the bow goes through the water by helping break up that surface tension on the forward portion of the ship. And our bulbous bow is actually optimized specifically for the speed range of our OPC design. So in addition to speed, sea keeping is a real main focus of the design, that being the ability for the ship and crew to operate in high seas. And that's improved through a number of the features you see on the screen. Up forward, you'll see a deep forefoot, that being the underwater portion of the hull, aft of the bow, but forward of midships being the middle of the ship. That deep forefoot reduces bow emergence and slamming during high sea states. The vessel has a low center of gravity that's balanced with stability and survivability requirements to limit motions and improve crew performance. The vessel actually has an aluminum deckhouse and a steel hull structure, which helps further reduce that center of gravity. you'll see active fin stabilizers aft, along with bilge keels. Those together provide passive for the bilge keels and active roll mitigation through the active fin stabilizers at high and low and medium speeds. Farther aft, you'll see a large skeg, which is longitudinal to the ship between the two propellers, that provides directional stability and also reduces some roll motions. And the freeboard of the ship, that being the side of the ship from the water up to the weather deck, and the bulwarks or the ship rails, the heights are chosen to balance reduced deck wetness with operational effectiveness. On the top right of the screen, you'll actually see a screenshot from some model tank testing. So as part of development of the design, we put the design through speed and maneuvering tests, as well as seakeeping tests, where the vessel was subject to really significant modeled sea states in a scale model. And the vessel performed very well, met all the contract requirements, and exceeded them. This slide shows more of the top side design features. So the OPC top side shares a lot of traits with other patrol vessels, but it does incorporate some unique features specifically tailored to the Coast Guard. So the pilot house, its forward location, where the ship is driven from, provides an operationally capable field of view. The forward deck house, also that being the forward portion of the deck house forward of the hangar, which you'll see aft, that being where the helicopter is stored, is split. The forward portion of the deck house provides some integral watch positions for migrant security and machine gun positions for law enforcement. Over the side working access is provided for the entire perimeter of the ship, which a lot of modern ships, the deck house will go all the way full width of the beam and might reduce that working over the side access, which this is critical for Coast Guard missions, as they're often having to retrieve, recover, launch small boats, etc. The split deck house configuration between the forward deck house and the aft for the hangar provides access amidships, that being across the beam of the vessel, and also reduces fatigue impacts. These vessels have a really stringent fatigue life because, as you've seen with some of the previous vessels they're replacing, the Coast Guard intends to use them for a very long time. The port and starboard boat deck areas are located amidships to reduce the roll motions and minimize the effects of the ship's motions on boat operations. That being the ability to launch and recover those small boats. And even the main machinery exhausts aft atop the hangar are offset to starboard, primarily to reduce exhaust flow into the path of a landing helicopter. So again, a very capable design, a lot of features that have been proven through 3D human systems integration modeling. You'll see at the bottom right where we actually put the 3D model of the vessel through human simulation to look at it for maintainability and operability, and even some physical modeling, as you'll see in the top right, for the anchoring evolution. So this OPC design effort has transitioned now into construction. So Eastern has 4 OPCs under construction, with the lead hull nearing launch in fall of 23. In these following slides, we'll get into the entirety of the construction process. So on this slide, you'll see the construction, fabrication, and assembly of the vessel. So initially, the process starts top left with CNC cutting the steel for the vessel. This cut is automatically based on the production design outputs from the design phase. And next, plates are shipped with specialized machinery to fit, shaped to fit the curvature of the vessel structure. So this portion of the build process requires really skilled equipment operators, people skilled in CNC machining, and a lot of other aspects that can be gained through career and technical education and other programs that we'll be able to highlight as we go through. So after that raw material is processed, that raw material moves into fabrication, that being when plates are initially welded together based on drawings, and panels being flat pieces of steel with cut stiffeners are welded to them, are fabricated. So this work is traditionally performed on a panel line or a platen. In this phase of the process, we see those stiffeners and framing added to panels. Efforts made to ensure that welding is performed in a downhand position, being you're welding towards the ground as opposed to overhead, as that actually improves the quality of the weld and reduces fatigue on the welder. This fabrication, as discussed previously, occurs on platens, which are flat, tolerance-controlled concrete foundations used to support fabrication, make sure it's accurate. So all these panels come together to form sub-assemblies in fabrication. After that fabrication step on the platen, the fabricated sub-assemblies move to assembly, where the panels that have turned into sub-assemblies are now formed into large units. On the bottom left, you'll see the underside portion of Unit 3 being one of the forward units of the vessel. So in modern shipbuilding, the method is to construct these units and then stack them together in order to come and form the entirety of the vessel's hull and superstructure. The advantages of this are such that the units or component parts can be built in sequences to suit the welding operations, which isn't always possible after the vessels are, after the units are stacked together or built in the traditional manner where they may lay a keel and then build the transverse structure out from that. During the unit phase, the unit will still be outfitted with some piping, foundations, and electrical components, which may also be best installed in that downhand position. So again, you're able to weld downhand on overhead portions of the ship because typically you build a unit inverted. That allows you to do all that overhand welding in the inverted position, and then you roll it to ship shape before you stack the units together. So during that fabrication and assembly process, we need a lot of welders, ship fitters being a specific type of a welding where it's more focused on tacking and actually reading drawings, putting together those panels, etc. And as we're outfitting the units, there's a significant level of pipe fitters that are needed, electricians who may be skilled in electrical foundations, and also machinists who may be better with foundation tolerances. So again, all of these trades can be learned through career and technical education programs at community colleges, some high schools, and even vocational and technical schools. So when the first two units are assembled together, that commemorates a ceremony called keel-laying, which you see in the bottom right. Keel-laying traditionally followed the laying of a wooden keel for a sailing ship. In modern shipbuilding, keel-laying is commemorated when the first two units are assembled. During the keel-laying ceremony, the ship's sponsor's initials are welded onto a steel plate to be installed in the vessel, where it will remain throughout the ship's service life to remind the crew of the strong bond between the ship and her sponsor. In this case, you're seeing the keel-laying for OPC Hull 1, and the ship's sponsor is Captain Beverly Kelly, the first U.S. Coast Guard female captain. So a really special event there at keel-laying. So the next slide, we'll get into outfitting and stacking of units. So from fabrication and assembly, we get into equipment loadout, which you'll see in the top left. So large equipment is typically installed after the ship is ship shape, or as discussed earlier, rolled from the initial inverted position into its upright position to be stacked together. We begin tracking and working towards more system completions, which quickly moves into system testing. So in the stacking phase, the individual units are lifted by crane or modular transporter and tacked and then welded together. So as the unit is lowered into place to be stacked, we have our accuracy control, which is another trade involved. Put the unit into ship shape, shoot lines to it, and make sure, based on references to the rest of the ship, that she's accurately coming together and aligned with other units of the vessel. So during this process, you'll actually cut additional stock or excess material on the outside of the unit to perfectly line it up with the units that she's fit into. So you'll start with tack welding the unit and then fully welding to the rest of the ship structure. After stacking, the units move more heavily, or even prior to, but move more heavily into paint and outfit, where additional painting and distributed system installation is installed into the vessel. The systems here include equipment, air conditioning or HVAC, electrical cabling, additional piping systems, and associated materials. So again, electricians, pipe fitters, sheet metal workers. There's a lot of skilled trades involved at every step here. In the bottom right, after the ship is fully stacked, she'll move into translation. So at various points in the construction process, the entire vessel may need to be moved through the yard. As you can see here, for OPC-1 to translate it into launch position, this vessel was actually put onto self-propelled modular transporters. So every one of the red wheeled vehicles you see underneath are controlled from a skilled operator with a single chest pack, who is controlling all of those modular transporters at once. At ESG, we'll also translate vessels through the use of rails, transporters, or cranes. So it's a really cool evolution and a fascinating one to be a part of. So after the vessel is translated into launch position, she'll move into launch outfitting and trials. So the video you're going to see here shows the launch of one of the 3 Staten Island ferries for the city of New York that Eastern delivered over the past few years. So for launch, as you'll see here, it's another exciting evolution. There are a number of methods that can be used. Some shipyards will use airbags to actually push a vessel longitudinally into the water on inflated airbags. A float out being whether that's an engraving dock or a floating dry dock, where the vessel's constructed in that graving dock or floating dry dock, and then the water level is raised in order to launch the vessel. And then gravitational and mechanical launching. So Eastern Shipbuilding uses a gravitational launch type system called side launching. This takes up a bit less space and build facility and safely launches the vessel, but in a really exciting manner. So again, after that launch, the vessel moves into final outfitting, and you'll see a lot of the spaces here. We just went through an engine room, and now we're looking at some passenger spaces aboard this Staten Island ferry. So during this phase, as you're outfitting it, you're also moving to test. Here you see the bridge of the vessel with sophisticated control systems. So the testing initially starts with equipment, then it moves to systems, then it moves to inter-system testing, where multiple systems come together, whether that's, say, your propulsion systems and your control systems coming together, and eventually into sea trials, as you're seeing here. So during a sea trial, you may also hear that referred to as a shakedown cruise. It's usually the last phase of construction and takes place in the open water. It can last from hours for smaller vessels or days, and depending on larger vessels. So sea trials are conducted to measure a vessel's performance and general seaworthiness in accordance with the contract and other regulatory requirements. So during this, there's testing of the vessel's speed, maneuverability, safety, equipment, and other features. So sea trial events are dictated by individual ships and the specific mission of the ship to be tested. So you'll see a lot of cool maneuvering here from these the Staten Island ferries. They actually have vertical cycloidal propellers that kind of look like fancy egg beaters called a Voith Schneider propulsors. So that's a real fascinating one to look into. So there's always something different in every shipbuilding contract, but that's one that's really cool to me. So after what brings the ship to life here is really the people behind it, right? So next we'll get into some of the careers that support building ships. So the first set here that you'll see is for engineering careers. So there are a number of engineering positions and careers at ESG in any shipyard. So these careers are highly technical. They can be entered from four-year college degrees and masters for naval architects or other functional engineers, or some technical programs at community colleges or technical schools will actually give you the skills to get into engineering as 2D, 3D designers, database administrators, document controls, drafting. So all these positions at Eastern are split into disciplines, and at other shipyards where you'll look at overall integration and others specific to some of the phases of ship construction and outfitting. Some specialize in piping systems, electrical, air conditioning or HVAC, and C5ISR, again, being electronics. In modern shipbuilding, we use a lot of 3D modeling in order to produce our production outputs, where we'll actually build the vessel in a 3D virtual environment, which then translates into the production outputs or drawings used to build that vessel. So those 3D designers, CAD CAM being a computer design tools, really require specialized skill sets and reduce the amount of man hours to build a vessel. So all the calculations, analysis, system design, bill of material development come from the engineering group, and they transform the concepts and the requirements of the vessel into an actual buildable set of information for our craftsmen. In addition to engineering, there are a lot of program management disciplines, a lot of which, honestly, I think are rather, you might not have heard of them. For example, you'll see across the left here, integrated logistics support, being experts who identify parts and requirements for maintenance, provide technical manuals for operation, maintenance, and installation, and some training requirements for equipment. Or EVMS being earned value management system. That's being a specific system utilized primarily on government contracts and sophisticated construction builds to plan, monitor, and control cost and schedule performance of programs. So there are a lot of professional and business degrees that are well suited for this line of work, not just STEM and technical degrees. And in addition, there's human systems integration, or HSI. You'll see at the bottom of the position list that are experts knowledgeable in the integration of humans into systems and performance analysis and test to confirm the safety and operability of ship systems. So you saw that previously on some of the design slides, where we actually put the OPC design through virtual human interaction in order to prove it was operable. Ultimately, program management is responsible for cost, schedule, and the scope of the program, or sometimes referred to as performance, and has to make trade-offs between them to make sure we maintain quality while hitting all the other requirements of the cost, schedule, and scope of the contract. So there's a lot of exciting careers in program management. And again, a lot of them can be entered through technical and STEM degrees and four-year colleges, and others are able to be entered through professional degrees. And of course, on top of program management, there's always the administrative side of business, including accounting, lawyers, et cetera, that are good ways into shipbuilding. And the lifeblood of every shipyard are our production workforce. So the production personnel fabricate, assemble, and deliver the vessel. The craftsmen and women here are what get a ship built, bring it to life, and are, again, the lifeblood of the shipyard. So there's a lot of opportunities here for yard management, vessel management, who are responsible for integration of multiple trades, superintendents, supervisors, foremen, first line craftsmen and women, the safety and quality assurance trades, who will actually make sure that we're performing safely and that the work performed and quality assurance is up to the standards that are required. So all these opportunities here can come through career and technical education programs at vocational and technical schools, community colleges, and many high schools, where you can learn disciplines like welding, piping, being pipe fitting and pipe welding, equipment operation, machinists who actually are specialized in the operation of individual pieces of equipment and machinery on the ship, whether that's the main engine or others, electricians, and other painting, scaffolding trades. And in addition, you can get into these with degrees as well, but it takes that level of vocational training to really master it. And aside from vocational training, Eastern Shipbuilding and pretty much any other shipyard has apprenticeship opportunities available, whereby you can enter as a general laborer or in an apprentice program and actually shadow through the build process, see if it's something that you want to do, find the trade that most interests you, and we can train you to become the trade that you would want to be, to build, operate, and maintain the vessel. So there's a lot of diversity, both in people and skill sets that build ships at Eastern Shipbuilding Group. So shipbuilding careers are inclusive. You can come to them from any walk of life, any ethnicity, any gender. And on top of that, you can come to them from any background, whether that's a career in program management, engineering, ship production, and the trades. There's a tremendous amount of diversity in shipbuilding careers and a lot of paths to get there. So we're always looking for new folks, and hopefully one day maybe this will interest you to become a shipbuilder and join us. So that's it for my presentation. Thank you so much, and I hope you enjoyed it. And this is just a small primer on shipbuilding and a lot of the opportunities that can be had building ships.
All right, well, thank you very much, Brendan. Here's a quick question. You were talking about the sea trials or the shakedown cruise. So during a sea trial, who is crewing the ship? Are they employees of Eastern Shipbuilding? Are they contracted crews? Are they members of the agency or company that ordered the ship?
Primarily, the crews are provided by Eastern Shipbuilding Group. So we do have qualified captains and mates on staff, and we can surge those as well through subcontracts. Certain vessels may have, from their owners, specific requirements to have them operate during some trials events, but primarily Eastern is responsible for providing the crew and operating the vessel during those trials.
Great. A question related to the offshore patrol cutter. I think you mentioned it, but could you remind us how fast do the OPCs go? What's their operational speed?
So their max speed is 22.5 knots. In addition to that, the offshore patrol cutter had a specific requirement, though, for maintaining loitering operations or continuous operations between 0 and 9 knots. So on top of that high speed of 22.5, our vessel design also has auxiliary propulsion motors in the form of permanent magnet pancake motors, not any bigger than this, that'll drive the vessel from 0 to 9 knots continuously. So those low speeds are important for Coast Guard operations, as well as the high speeds to do the exciting stuff.
Yes, a follow-up on that. The small motor for pancake sizes, you said, for the slow speed operations. Does that impact the fuel economy at all with the ship, fuel consumption and things like that?
It does. So you'll actually, to engage these electric motors, you engage a power takeoff on the gearbox to switch from the main engines to these pancake motors that are attached to the gearbox on what's called a spline gear. And from there, those are driven through a variable frequency drive attached to the diesel generators. So you're actually able to shut down your main engines and operate your propulsion on your diesel generators, improving fuel efficiency and reducing wear and tear on those main engines.
Great. Maybe a question related to the fabrication process of the OPC. So first, approximately, if you're talking, say, the hull, how thick is the metal that you're fabricating? And the second question is, you're using a lot of metal here. What's your supply like? Where do you get metal from? How does it get to your shipyard, maybe?
Yeah. So for thickness, it depends on the area of the vessel and the requirements. There are some areas of the skin of the ship that are 1.5 inches or up to 2 inches thick. A lot of places, though, you'll see anything from 5/16 and up, and that's for plate. In addition, there are stiffeners, which can be fabricated tees, where you'll actually, have 2 pieces of flat steel flat bar welded together, or bulb flats, where it's actually kind of formed and looks about like that. And those have varying thicknesses as well. For steel supply, we source a lot of our steel through suppliers and distributors in Alabama, as well as West Virginia, for some steel. So there's a lot of domestic supply for distribution that we utilize, and you have to get specialized American Bureau of Shipping or other regulatory agency approved steel as well. So it does get challenging in some of the shorter supply chain timelines, like we have had with COVID. However, we've been able to overcome that and continue building through that process.
Outstanding. Another question here, more on the people side of the cutter. Is the OPC designed to host male and female crew members?
She is, absolutely. So absolutely designed to host male and female crew members. A lot of advanced accommodations type spaces. For example, there's a full law enforcement locker and a locker room that I think is a real boon for medium endurance cutter areas. There's male and female facilities in that law enforcement locker room, and it really allows the crews to, say, get on and off of a small boat, be able to put away, say, their what might be stinky gear after they've gone on a fishery enforcement mission, rather than having to haul it back to their accommodations, as may happen on some smaller or legacy cutters.
All right. How about production timeline? How long, really from start to finish, maybe finish being up to sea trials or delivery to the Coast Guard? How long does that OPC take to make? I know it's a complicated question. I guess it depends. What's the start point of? Well, maybe that's a good question too. What is the start point of building an offshore patrol cutter, and how long does it take?
So I've been working on the offshore patrol cutter program for about I think 9.5 years now. So, but that was to your point, from preliminary and contract design. We cut steel for OPC Hull 1 in September of 2018. We were awarded in September of 2018 and cut steel shortly thereafter. So we're still continuing to build to this day with delivery in 2024. So that timeline is significant on Hull 1. That's impacted by some things, hurricanes, COVID, and other things that have slowed down some of that process. However, generally speaking, the vessel ultimately on a longer run will reduce down to 3 or 4 years, but it all depends on a lot of the build processes and things like that.
Great. And earlier in the presentation, you were talking about the OPC in terms of long tons, so all of the weight combined. But in terms of numbers of ships, approximately how many cutters will be, how many OPCs will there be delivered to the Coast Guard, do you think?
Yeah, the program of record is 25. So, but I think that's to replace more than 25 medium endurance cutters. So, the National Security Cutter Program did go from, I think, 9 of program of record to 11. So there's opportunity on the back end of the program for that to increase, but currently the program of record is 25.
Fantastic. So that is going to be the backbone of the Coast Guard fleet there.
Absolutely.
This was an outstanding presentation. I'm not seeing any questions. If there are any more, you can type them in as we wrap them up. But I'd like to give you another big thank you, Brendan. Really interesting presentation, a lot of great information about the new OPCs that'll be joining the Coast Guard cutter fleet, as well as, you know, all of the different types of jobs and careers that it takes to get these cutters built. So fantastic. Thank you very much.
Thanks for having me.
All right. And if you're watching the recording of this on YouTube, please do share the link with your shipmates in your Sea Scout ship or in your flotilla to pass along the wonderful information and to learn more about shipbuilding and the future of the Coast Guard. I hope to see you next month on August 22nd for our next Tech Talk at 9 p.m. Eastern, which will be on radar, presented by the National Weather Service Radar Operations Center. Have a good night, everyone.